works. Okay, 2.5. Actually, here's a look ahead for the end of this chapter. 2.5 is the last section we're covering for this half of the chapter. So then that means I usually take 3 days to cover 2.5. So that means today, Wednesday, Thursday, leaving do plan on a homework quiz Friday, but Friday would be the first day of review. Monday, also review. Tuesday test.
So that'll be on that last homework that we had through.
Yes.
All of them?
Stick to the IVT, I think that would be something.
Well, yesterday was the first one,
And then
and then these next 3 days, yeah.
Oh, perfect. This is Dreesville. I actually knew what we were doing.
Good. Glad. You do. I have a worksheet though.
Oh,
Yay.
nice.
Worksheet today.
Yes.
Worksheet.
I know.
What?
I like worksheets. Just do it.
I killed extra trees for you all today
Thank
You're welcome.
Thank you.
I love that
Teacher
part.
of the year.
for killing trees. All right.
But just think how many trees they killed to make those backstairs.
Well, yeah, but they were killed a while ago.
But now we're killing more.
Now we're killing extra trees.
But that's okay.
So we need to get going if you want to have time to work. 2.5 is all on limits that involve infinity. So what that could mean is your limit could equal positive or negative infinity. Your limit could be as x is approaching positive or negative infinity, or a combination, maybe as x approaches infinity, your limit also approaches infinity. So we're going to be looking at these limits that involve infinity today, specifically infinite limits. These are limits where your x value is still approaching a specific number, since infinity isn't a number. So in example 1, it says find the limit as x approaches 0 of 1 over x squared. So by the methods we know already for how to find a limit, if we use direct substitution for this, we would have 1 over 0 squared, so 1 over 0. That is undefined. So what would we say as the value of this limit? If it's undefined. It doesn't exist. Okay, so I could have given you this on your last quiz. You hopefully would have said the limit doesn't exist. And that is true, even though now I'm going to build on that. The answer of saying this doesn't exist is still correct. The limit doesn't exist. That isn't changing. However, if I were to go back to the first method we learned for finding or estimating limits by making tables, yes, numerically. So I want to pick some x values that approach 0 from either side, from the left and from the right. So in this first table, I'll say x is approaching 0 from the left. So values less than 0, I'll just do, say, negative 0.5, negative 0.1, negative 0.01, negative 0.001. And then when x is approaching 0 from the right, I'll use the opposite of each value. So just the positives of those. And I'll use my calculator to get these values. My battery's low, so hopefully my calculator will work. I know. So my function is 1 over x squared. And I actually, I have these values typed in probably from the last time I did this. And it will change your y values when you change your function in there. So at negative 0.5 and positive 0.5, so the values on either side are going to be the same. It goes from 4 to 100 to 10,000 to Your calculator's in Spanish?
Yeah.
Interesting. To a million. So if you ever see this on your calculator, it says 1e6. That means 1 times 10 to the 6th. That's scientific notation. But remember, you can always hover over that, and it'll give you more decimal places or just more place values in the number. So it's a million. So what do you notice as x is approaching 0? What's happening with the y values? They're getting infinitely greater. Even going from 0.5 to 0.1, it's jumping from 4 to 100. So yes, it's growing infinitely. So even though this limit doesn't exist, that fact is not changing. We can now explain the way it doesn't exist by saying that this limit is equal to positive infinity. So this is another way we could answer that question. So if you say it equals infinity, I want to make this clear. It still doesn't exist. The limit does not magically exist now. It's not different. But it's just showing, even though it doesn't exist, it's still explaining what the y values approach. It's showing they're approaching something infinitely large. They're not approaching a specific number, but they're growing infinitely larger. All right, so that is what's explained. The rest of this page is kind of looking at some notation and explaining those ideas. So if you see the limit as x approaches a of f of x equals infinity, it means the y values f of x can be made arbitrarily large as we please by taking x sufficiently close to a on either side of a, but again, not equal to a. All right, I need it quiet, please. I'm talking over a lot of people right now. I word this the exact way it's worded in your textbook, so if you're kind of looking back and forth, it's not different. But again, this is just showing your y values are becoming infinitely large as your x values approach a. It does offer you another notation for this, so rather than having this limit notation, we could say f of x approaches infinity as x approaches a. It's a less common notation, but if you see that, it means the same thing. The symbol infinity, remember that's not a number, but that expression we often read as, and here's 3 ways it could be read. So the limit of f of x as x approaches a is infinity. F of x becomes infinite as x approaches a. F of x increases without bound as x approaches a, are just different ways it can be worded. And then what follows this, I don't want to read through this whole thing for you, but similar definition if the y values are becoming infinitely large in the negative direction. So you can also say that the limit would equal negative infinity, and that means it's just decreasing infinitely. So there's very similar notations and wordings there if you have negative infinity. And then there's also similar definitions for one-sided infinite limits. So notice, what do we call this on a graph? If you have an infinite limit, what's happening on the graph at A? There's an asymptote, yes. So this is showing, and an asymptote, we're going to look at a specific definition. We can find vertical asymptotes by using the definitions of infinite limits. So for something to be considered an asymptote, it just has to have a limit of positive or negative infinity on one side of the value. So that's actually at the top of the next page. The line x equals a is called a vertical asymptote of the curve y equals f of x if at least one of the following statements is true, and it gives 6 of them because, again, it could be the entire limit as x approaches a equals positive or negative infinity, or just from one side, just from the left or just from the right. If it equals positive or negative infinity, then x equals a is considered a vertical asymptote. So, in example 2, and here's what I'm going to be looking for now, and what they look for on AP as well. if I were to give you a problem like this, even though does not exist is true, I am looking for the answer to be infinity. And remember, you have to know how to do this without graphing the function to say, oh, they're getting infinitely large in the positive direction. So I'm going to show you ways to find whether it's positive or negative infinity without looking at a graph, because you have to know how to find it without looking at a graph. So in example 2, I've kind of given you more of a hint for this one, where I'm saying find the limit of this same function as x approaches 3 from the right side, from the left side, and then just as x approaches 3. So if we first look at the limit as x approaches 3 from the right side, you should still use direct substitution first. Yep, so we get 6 over 0. Okay, and now rather than saying doesn't exist, I'm going to see if doesn't exist means it's approaching positive or negative infinity. So to know which one it's approaching, I'm going to check for the ratio here. Is it a positive or a negative ratio of 6 over 0? Because again, the denominator doesn't necessarily equal 0. It just means the denominator is approaching 0. And I want to see, is it approaching 0 from positive values or negative values? So if I am approaching 3 from the right side, are my x values less than 3 or greater than 3? Greater. So my numerator is approaching positive 6. That means that's a positive number on top. So I can either put a plus or I'll put positive here. And either direction I approach 6 from, as long as I'm close to 6, my numbers are still positive. 0 is where on either side of 0 you either have negative numbers or positive numbers. So if I'm approaching 3 from the right, the x values I'm plugging in are getting closer to 3, but they're greater than 3. Meaning if I take numbers that are greater than 3 and I subtract 3, are those numbers going to be positive or negative? Positive. So I'm thinking like if I plug in 3.1, 3.01, 3.001, I'm getting closer to 3, but they're all bigger than 3. So when I subtract 3, I'm getting positive 0.1, positive 0.001, and so on. So even though I'm approaching 0, I'm approaching 0 from a positive standpoint. So my ratio ends up being positive over positive, meaning this limit is going to approach positive infinity. Does that make sense? Well, I'll say this. We have two other ones to look through right now. So this one is approaching positive infinity. So if I approach 3 from the right, my y values are getting larger and they're positive. Now if I look at the next one, so now I'm approaching 3 from the left side, still of the same function. So I know with direct substitution I still have 6 over 0. I'm just going to write 6 and 0 here. But now approaching from the left, my x values are less than 3. Yep, so now my 6, still if my values are less than 3, I'm still approaching 6 from a positive standpoint. But now the 0 here, so I'm taking numbers getting closer to 3 like 2.9, 2.99, 2.999. And if I subtract 3, those numbers are now negative. So my ratio is positive over negative. That's a negative ratio, meaning this is approaching negative infinity. Lydia? The 6 is still positive because even if I approach 6 from like greater than 6 or less than 6, I'm still close to 6, and on either side of 6, I'm still positive. Does that make sense? But if you're on either side of 0, that's 0 is the break where you have negative numbers on one side and positive on the other. So the 0 is really what matters. So then if from one side I'm approaching positive infinity and from the other side I'm approaching negative, what would I say the limit as just x approaches 3 equals? It just doesn't exist. So this I would still say doesn't exist because on one side my y values are getting infinitely large in the positive direction. On the other side they're getting infinitely large in the negative direction. They are not approaching the same infinity. So I would say doesn't exist. So if both sides approach positive, then this would equal positive. If both sides approach negative, it would equal negative. But if it's one or the other, we say it doesn't exist. But you still have to check. Don't just automatically say a limit doesn't exist. You should check to see if you can, I guess, go further with it and say positive or negative. Dalton? Yes. Yes. Yeah, so his question was if you were giving a reason for this, you could still say it doesn't exist because the limit from the right does not equal the limit from the left. And he was just asking because technically from both sides, each limit, even though we can say positive or negative, they still don't exist. But this is still perfectly acceptable if you had to give a reason why. Okay, so that's one example. Now, the examples are not going to be set up this way. The examples are going to look more like just example 3, where this says just find the limit as x approaches 3 of the function 9 over the quantity x minus 3 to the 5th power. So if you just saw this, now we're in this section, you're probably thinking, well, yeah, it's going to be 0 on the bottom. Now, if you just saw this, though, still use direct substitution, we get 9 over 0 to the 5th, so 9 over 0. So when you see this, again, don't just say doesn't exist. It's possible it is doesn't exist, but don't just say that. You have to check the one-sided limits. You have to see if from the left and from the right, they would approach the same infinity. Does that make sense? And that's why I broke it apart for the first one, but this is how it's going to be given, and you have to know that you need to find the one-sided limits. And I'm thinking, too, if this was a multiple choice question on the AP test, they're probably going to give you 3 of those responses, 3 of the 4, 3 of the 5 are going to say positive infinity, negative infinity, doesn't exist, or something else. You need to know which one you're going to say. So you do need to find the one-sided limits because if from both sides they do approach positive infinity, that's the answer they're looking for. So if I find the limit as x approaches 3 from the left, okay, I know it's 9 over 0. What I'm really looking for with the one-sided is the ratio. Is the ratio positive or is the ratio negative? So the 9, however I approach 9, that's positive. On either side of 9, it's still positive. But I'm approaching 3 from the left, so my x values are less than 3. And does that mean the 0 on the bottom, that I'm approaching 0 from the negative side or from the positive side? From the negative side. Numbers smaller than 3, subtracting 3 is negative, to the 5th power is still negative. So this would be a negative on the bottom, meaning from the left, it's a negative infinity. And then if I find the limit as x approaches 3 from the right, so again, the 9, either side I approach it from is positive. Now my x values are greater than 3. So if I take a number greater than 3, still getting closer to 3, subtract 3, it's positive, to the 5th power, it's still positive. So then this side is approaching positive infinity. So what would I say for my limit here? Doesn't exist. Yes, Clifford. For me, well, if this was like a multiple choice question on the AP test, well, multiple choice, you don't have to show any work. They're not looking at your work. If it was thinking free response, and this is how I would want you to answer it, if they asked this as a free response question, they'd probably include after it, justify your reasoning, in which case, if you're saying it doesn't exist or one or the other, you're going to have to show the why part of it. So I guess to answer your question, if it's multiple choice, work doesn't matter. If it's not multiple choice, I'm going to be looking for your work. AP would be looking for your work to justify why. And more for me, it's so that I know when you take the AP test, again, I'm assuming you're all taking it, whether or not you are, I teach all of you as if you are. I want to make sure you know that on the AP test you would do that. So that's why I'm looking for you to do it, regardless of if it's multiple choice or not. Okay. I know I have example 4 there. Why don't you look at example 4 without me? So find that limit. If it doesn't exist, be able to show why it doesn't exist. Yeah, this is all I'd be looking for you to say. So if I can see this, yeah. Yeah. I'm just looking to see, do you know what the two one-sided limits equal and then they're not equal to each other? Yes, so that would be perfect.
Why, Rod? Is that Rod? Rod.
All right, double check yours. I know some of you on the other side of the room, sorry I didn't check yours too closely. I wanted to make sure you had a chance to do it, but if you're just waiting, I want to move on. So double check though, this is what I would look for. Not only does it not exist, I want to see that you know from the left side it equals positive infinity and from the right side it equals negative. And therefore it doesn't exist. If you had positive infinity for both, just keep in mind your numerator is always approaching negative 12 for this one, so your numerator is always negative. Questions on example 4? All right. Then, for example 5, this is also a question you might see, and you are using limits to answer the question. So it says, find all vertical asymptotes of the function. No, you are not graphing this and telling me from your graphing calculator this is where an asymptote is.
Oh, wow.
Because again, this question would not appear on a calculator part of the test. It would appear on a non-calculator part of the test. I know, right? So you have to know how to do this without graphing it.
What?
I know. Set what equal to 0? Well, that's part of it, yes. All right, so I need your attention, please. In order to find your vertical asymptotes, first find, I call them the candidates. I mean, you don't really need to write that out, but looking at your function, think about where would this function have a vertical asymptote. So, where?
Probably where the
Yes. So the values that make the denominator 0 are the possible places you would have an asymptote. So that means it's possible to have a vertical asymptote at x equals -5 as well as x equals 9. Now, that's not all you have to do. Maybe, yes, these are both vertical asymptotes, but there has to be work along with this to show whether or not they are asymptotes. This is how you show it, again, to justify your answer. Thinking back to this definition, all you have to show is that from one side, as x approaches those numbers, that the limit is either positive or negative infinity. That's all you have to show to prove that it's an asymptote. And I say from one side because as we just saw in these 3 examples, you're finding the one-sided limits anyway to find the overall limit. So if you look at example 5, I would need to show or find the limit as x approaches -5 from one side. I'll just show from the right. I like to deal with numbers greater. I don't know, it doesn't really matter though. Of my function, -8 over x plus 5 times x minus 9. I need to find that limit, and I need to find the limit as x approaches 9 from at least one side. So I'll approach 9 from the right as well. And if I can show that these limits equal positive or negative infinity, that's enough to say that there's a vertical asymptote at both of those x values. Oh, yes, yes. If you just put f of x instead of the expression, that's fine. Yep. All right, so if I am approaching -5 from the right side, so I'm approaching with values greater than -5, I know I'll have 0 in the denominator. I know that from getting -5 in the first place. But the numerator is negative. The denominator, would the denominator be negative or positive if you are plugging in values larger than -5? Negative? All right, so this term here would be positive if your numbers are bigger than -5, but the x minus 9 would be negative. Product would be negative. So that means this is approaching a positive infinity. This tells me there's a vertical asymptote at x equals -5. So because of this, I can say, therefore, x equals -5 is a vertical asymptote. And I blended my T and my E there, sorry. And then for the second limit, so now I'm approaching 9, I realize my denominator is 0. My top, again, is still negative. If I substituted numbers larger than 9, would my denominator be positive or negative? So x plus 5 would be positive, x minus 9 would also be positive. So that means my ratio is negative. Negative over a positive. But this is enough to say then, therefore x equals 9 is a vertical asymptote. So when wouldn't it is the question. If, remember there's cases where I might substitute in a number and the denominator is 0, but the numerator is also 0. So if you get 0 over 0 and then you can simplify it and you get an actual value for your limit, it would be a hole in the graph and not an asymptote. So it is possible that whatever makes the denominator 0, it doesn't have to be an asymptote. But this is what you would need to show as a reason why. Does that make sense? Are there questions on that? And if, in any case, if you're asked to find the vertical asymptotes, this is the work you would just need to show. Example 6 is the same type of example. And then all I included at the bottom, this isn't an example, but these are just two familiar functions that have vertical asymptotes. So we could write limits to show their vertical asymptotes. For example, if I have the limit as x approaches, I know 0 is a vertical asymptote. So if I approach the x value 0 for the function y equals natural log of x, and I'm only going to approach from the right side because the curve itself doesn't exist from the other side of 0. That limit is negative infinity. That's enough to say that x equals 0 is a vertical asymptote. And then tangent, this is y equals tangent of x, has numerous asymptotes. If I just picked one, say at the x value pi halves, and I could really approach from either side. But if I take the limit as x approaches pi over 2, let's say from the left side of tangent, from the left, I'm approaching positive infinity, and that's enough to say it's an asymptote. Notice, though, the limit at pi halves, not that this limit exists, but the limit at pi halves wouldn't exist because from either side you're approaching opposite infinities. But those are functions that do have vertical asymptotes. So